It's about 4. And you might wonder, why is there such a weird looking page at the front of this workbook? You don't have to worry about this part, but this is what the province, if you look at the precision measurement at the bottom of that, that's what I want you to focus on. If you need to review what accuracy is, what precision is, it's all there one more time based on what the province, that's what the province would like you to know about accuracy, about precision. Follow along now. This is the workbook, okay? We basically, you know, this paragraph right here, that was in your AC just now. You should know which one is more precise. What instrument is more precise? So we just did that, right? So they kind of want you to know that. And then if you flip to the back side of that front page, it reviews what uncertainty is and combined uncertainty as well. This is your workbook, right? Uncertainty is half the precision. It is expected that students are able to calculate, right? You're supposed to calculate the total uncertainty when using a device repeatedly, right? Or when making cuts and so forth. So there's an example of how that would work. So we went up to here, and today we're going to start talking about tolerance. I want to read that one together. I like their definition more than the textbook. It says tolerance is a range of acceptable measurements, right? Just highlight that, the range of acceptable measurements. Here's a new word for you. The nominal value is the target measurement. The nominal is the target. That's what we would, ideally, that's what we would want every single time. But we can't get there because of machinery, issues with the machinery, limitations of the measuring device, and so forth. And I will stop there. I just wanted to highlight that's why I inserted that page onto your workbooks, so you have that ready to go. Back to our notes now. Tolerances. I want you to highlight what it says on the side here. Tolerance is the measurement variation allowed, right? So an item is still acceptable for its intended purpose. Right? When you tolerate someone, a person, right? You're putting up with certain things, right? Because you still want to keep that friendship going. So there are certain things you'll tolerate, but if you go past certain lines, it's going to be over, right? With any kind of relationship, right? All right, here. I want you to highlight in the manufacturing world, a range of sizes is often acceptable. So I'm throwing a lot of ways to think about tolerance. Okay, for example, if you're making a mortise and a tenon joint, as shown in the diagram below, the tenon needs to be small enough to fit the mortise, but large enough that it will not fall out. Okay, small enough to fit, but large enough that it won't fall out. The range of acceptable values is called tolerance. So there's quite a few ways of thinking about that. And let's label this thing. That is called the tenon. And the hole that is made on the other piece It's called the mortise. Anybody ever made a joint like that? Yeah? So, right, like if you're off, right, it's going to be all wiggly like a chair if you put a chair together. And this piece is too small, it's going to be all wiggly, right? Or if you make the hole too big, it's going to be all wiggly. But we do have a range. We are allowed to vary a little bit. Why do you think we're going to have to allow for measurements to be off? What are there some reasons that we would allow for measurements to be off? Why would that be? You can adjust if it's too big. If it's too big, you can just make it a little smaller, right? In this case, yeah, you can make adjustments. But tolerance, I'm going to add that on the back side. I'm just going to talk about it now. But everything has a bit of tolerance. For example, if you plug in your phone, right? If you're charging it, the electricity coming into your and out of that outlet is not always the same. It goes up and down. If I don't have my voltmeter on me, but if you were to measure the voltage coming out of that outlet, it's not always 110. It's going to be 115, 108. It's going to fluctuate. So when they make your iPhone, right, or Samsung, whatever you have, iPhone is better. I'm just saying. I'm just saying. I'm just saying. But that's besides the point. If they got that wrong, your iPhone would be fried, right? If something went wrong, if there's a surge, like sometimes in the power lines for whatever reason, there's a surge, right? It actually goes up significantly when there's a storm and stuff like that. You don't notice it, but your fridge, all your appliances, they can withstand some variation. They allow for variation, or else it would fry, right? Um, when they if you got your vaccine, we all got a vaccine, or a lot of us got a vaccine during the first COVID crisis, right? Uh, that dosage you got, you think it was the same, exactly the same for everybody? No, there was some variation, right? Like sometimes it wasn't measured properly. There were variations there, but it's okay when they come up with that dosage. It allows for some variation, right? It can be off by a little bit, not by much, but it is allowed to be off by a bit. Okay, so that's tolerance. That's what that is. So write this down. The tolerance is determined by subtracting the minimum acceptable and the maximum acceptable value. So write this down. Tolerance is maximum minus the minimum. When known, when unknown, right? That's very important there. We assume that the nominal value is halfway between the minimum and the maximum. So the nominal, this is our target, is going to be max plus min. What are we going to divide it by if we want the average? Two numbers are being added. We would divide that by 2, right? So we have that formula there. I'm going to box that in. And this is the painful part, but I will show you enough examples where you're going to make this work. At first, the first couple of exams, students were terrible at this unit. And the main reason is because teachers didn't even know what to do with it, right? It's like, I don't know, I don't like it. I'm just going to go over it and then boom, right? But it's actually not bad. It's actually very beneficial, in my opinion. So this is one format. There are 4 ways, highlight that part, 4 ways to state this. You can have this on your study sheet. You do not need to memorize this, right? Maximum, minimum. So you will, for example, have, let's say, something that was produced, right? You know, medication often says, right, cannot be below a certain temperature, right? It cannot sit, it can be on the higher end, but it can't be too low, right? So this is how in the industry they would state that. Watch this, guys. Nominal is unknown in this case, okay? We don't know what the target value would be in this case. Let's say you have something that's stated in this format, and I will give you an example. Let's say you have 45 millimeters plus or minus 1/2 of 4 millimeters. That's an example there. I'm going to chop this off here, okay? Just not all, just like that. There could be one like this. So this is where you have the minimum value. Let's say it's 43 milliliters. And you have minus 0 milliliters plus 4. Let's change this to 5. Okay, 5 milliliters. Or you could have this here, where you have, let's say, 105 yards plus 0 yards minus 6 yards, let's say. You know what I want you to remember out of the 4? That immediately, without even thinking about it, the first number for every single one of these 3 is called our nominal or target. Okay, so we're going to go like this. So if I ask you, hey, what would be the target in each of these 3 scenarios, you should not even have to think about it. You just go grab that first number. With this one, you have a problem. You don't know it. So we would assume it's halfway in between, right? But in this case, those are the 3 that you need to know. Why would you state it in 4 different ways? I don't really know, but I do know that, for example, this one right here, they were making an argument that for an airport runway, when they say, hey, this runway has to have like 2 kilometers in length, it cannot be any shorter. If you want to make it longer, sure, go for it, right? But you can't make it any shorter. It's just not acceptable, right? Because it's for safety reasons. You don't want to run out of runway, right? And then in this scenario, it could be if something isn't supposed to be past a certain temperature, right? If there's at some point that thing would melt, right? You'd probably say, hey, you can't go higher. You're allowed to go lower, but you can't go higher. Then you'd rather state it this way, right? And notice that I put units everywhere, right? I put units everywhere, so you know that that is supposed to follow, okay? So these are your 4 ways, guys. Okay. I'd strongly suggest you add these to your study sheet. Okay. You know what's cool about these? You can go, if I give you any one of these, you can go and convert them into the other 3. Okay. All right, here's the example. Let's go to the next page on 93. I'm going to give you this example here. Let's say 15 centimeters, 12 centimeters. Sorry, why is there MCM? That's not even a unit. So 15 centimeters, 12 centimeters. Figure out the max, the min, The nominal, sorry, can I change this to tolerance? I want all of them to be the same. So if I asked you, hey, fill out these four pieces of information, because if you have these four, you can actually rewrite this tolerance in the other three formats. Okay. So sorry, don't overthink it, please. Some students overthink this. It's actually not that bad. If you have them written like this, what do we know about the top number? And that is our max, right? Okay, you should see this and it should remind you of that. That's why I have it like this. So 15 centimeters. What's my min? You guessed it, 12 centimeters. How would I find the tolerance? I just gave you that formula earlier. You take the max, you subtract the min. So there's a 3 centimeter tolerance between the max and the min. How would I find the nominal? That's right. It's unknown here. This is the only one where nominal is unknown. Remember that. So it's 15 plus 12 divided by 2. And make sure there's a bracket there. Okay. Please remember that just in life, if you ever have something adding and that being divided, it's assumed that you're going to put brackets on. That should happen first before you divide. Okay. So this is what, 27 divided by 2, which is 13.5 centimeters. This is what we assume is the target in this scenario, right? They're saying, hey, we want you to build these pieces or to cut these pieces. This is what we want, but you can go as low as 12, as high as 15, and it would still be acceptable. So let's write it in the other four ways. Sorry, I kind of used too much space here, but nominal plus or minus half the tolerance. This you would have on your study sheet. You would not have to memorize this. The nominal is this, plus minus half of, what's the tolerance in this case? You just go pick it, right? We already figured everything out. It's 3 centimeters. Okay. Let's say I wanted you to write it like this: max plus 0 minus tolerance. That's the other format. What's your max in this case? It's right there. Plus 0 centimeters minus, what is the tolerance? It's 3. Bingo. Like let's box all of these in here. This is the other format. This is another format. So technically you started with this format. So it's 1, 2, 3. We have one left to do, which is min minus 0 plus the tolerance. And so in this case, the min is what? 12 centimeters minus 0 centimeters plus 3 centimeters. Okay. Once you have these four, you can go and figure out the others, right? Max, min, tolerance, nominal. Just if you do this every single time, like I'm going to give you one, you fill in these four, and then you go out and state the other three, right? So I'm going to give you one, you need to figure out the other three. Is this too much? Let's do it one more time. You can do it, guys. Come on. Okay, I'm going to give you another example. So let's say this is the one I give you. So I'm going to go 17.5 millimeters plus or minus half of 0.4. And I ask you, please give me the other three. Right? And you're like, no problem. I will figure that out just now. So I'm going to go max, min, tolerance, and what's the last one? Nominal. In any order you would like. Which one do I know right off the bat? I highlighted it on the previous one. Somebody says tolerance. I'm thinking nominal, just because that's the first thing I see, right, when you read it. So that goes right here. It's given. You don't even need to calculate that. Mark, you said tolerance, right? Yeah, that's the next one. Sure. And if you put that down first, by all means, go for it, because there is no order. Okay. And now you need to do a little bit of work for the other two. But this is telling you what you need to do. The max would be what? 17.5 plus, what's half of 0.4? 0.2. I did it on purpose, but sometimes you might have to use a calculator because those numbers might be a little challenging. That's 17.7 millimeters. To get the min, I'm going to go 17.5 minus half of the tolerance. You mean I have to do math? A little bit. Now we have a bit more room. I'm going to ask you to state it like this, max min. I want you to state it like this, max plus 0 minus tolerance. And I want you to state it like this, min minus 0 plus tolerance. Can you do that? Go for it. 7.3 minus 0 millimeters plus 0.4. Done, right? All three stated just like that. Did I get it right? Please let me know. Sometimes I get it wrong because I'm distracted. Okay. I'm going to give you two more examples. We may or may not have an AC on it today. We'll see. What if I gave you this? And down here, I'm going to say oh yeah, this is going to throw you for a loop. You can handle it, but you can be like, what? So max, min, tolerance, nominal. Max, min, tolerance, nominal. Fill that in. And then figure it out in the other three formats. I will write them down. I'll be nice. There are your three. So these are the three that I want you to convert this to. humor, as long as you're polite and kind. All right, let's do this. You ready? I truly believe that at the end of the day, you should have a pretty good grasp. Okay? Of course, don't feel too bad if you don't. All right, just follow up here, okay? Guys, doesn't it beg, like if you have a number and there's a plus there, it should tell you that, hey, if I add these two up, that's the maximum temperature allowed under this scenario. So I actually would like you to do this, right? 7 degrees Celsius is the max. The min is 5 minus 0. Just follow along, okay? No talking now. 5 minus 0, that's your min. The tolerance is the difference. Always the difference. That's why I'm asking to put the max and the min down first. So that's 2 degrees of a tolerance. The nominal, just put an arrow. It's straight from that. If you have a big number in the front, that is your target every time. Five minus 0, so it's just 5. That's to get your nominal, you went, okay. I'm actually glad it happens, because I think you're thinking this formula right here, right? When unknown, like when we don't know it, we use this. And the only time you won't know it, Meninder, is when it's like this. You only use this when it's like max min like that. But any of the other formats, automatically the front number is your nominal. Okay? Perfect. I'm glad it happens, Meninder. Don't feel too bad. Okay? As long as you keep trying, I don't care if you make a mistake. Okay? Next, max plus 0. So we grab our max, we go plus 0 like this, degrees Celsius, minus the tolerance. The tolerance we determined is 2 degrees Celsius, right? From here, we just plug it in. The next format I asked you to write it in is nominal, which is 5 degrees Celsius, plus or minus half of what the tolerance is. And for us, the tolerance is 2 degrees Celsius. As I'm telling you, these are the pieces you need to write all of the other ones. What's your max? I'm glad you asked. I already figured it out. Your min is 5 degrees Celsius. And doesn't something seem weird about this? You see that the min is also the nominal? That's okay. It happens. That's just fine. It will happen from time to time. Okay, one last. This is the province did this to us, and they didn't tell us they were going to do that. And what seems to be off here? Does it fit any of the formats that we gave you? There should be a 0 somewhere, right? Like students were saying, like one of this should be a 0, and they just couldn't. I know you would. I know you would figure it out because I'm preparing you. But to get the max, you just proceed as before. Honestly, this is a foolproof, works every time method if you do it this way. Minimum, you take the 45.05 minus 0.03, and that's 45.02. How would I find the tolerance? It's the difference between these two. And that is 0.05. And what's the nominal? Right here, 45.05 inches. And I kind of ran out of room. So here we go. If you want to write it like this, keep in mind I will not tell you necessarily which one you pick. as long as you have the other three. So the minimum is 45.02 inches minus 0 inches plus, what's the tolerance? 0.05 of an inch. Done. The next format looks like this. My nominal is right there, plus or minus. My tolerance is 0.05 inches. Done. Second format is done. This is the easiest one of all, this one right here. You just grab those two numbers and stack them, right? 45.07, which I determined to be the max, and the min is 45.02, which I determined to be the min. AC tomorrow. However, I want to say something right here. Pay close attention to what I'm going to say here. Tolerance is dictated by the industry. The industry will decide what the tolerance is. What are the acceptable values for our purpose? Why is there tolerance? Is due to uncertainty and human error. Human error and uncertainties is the reason for tolerance. If you're working at aerospace, a lot of those parts will have a very small tolerance. They will not accept, unless that sheet of metal is exactly what it's supposed to be, it's not going to be accepted. Other industries, not such a big deal. If you cook meat, anybody work at a restaurant cooking? You got to make sure the temperature is right, or else trouble, right? You might it might cause I'm running out of words. Food poisoning, right? If it's too high, the steak will be too dry. Your customer will be upset, right? So every industry has a tolerance.